functions rather than network entities. So all the generations, second, third, and fourth generation had various network entities, and these are now network functions. And we talked about all of these things here. These network functions use services, they produce services, so they're both a consumer and a producer. The myriad of the different protocols through the second, third, and fourth generation, like SS7 and diameter, just to name a few of them, they're pretty much reduced now to HTTP2. So we looked at some of the functions that that happens in 5G, because again, just because it's a software defined network, you still have to do certain things. You still have to have access and mobility. You still have to manage the session. You still have to do policies. You still have to have a home server. So there are different functions, but again, these are not done in dedicated network entities anymore. This is, I believe, where we ended up. Some of the identities that have been around for second generation, third, and fourth generation, like the International Mobile Equipment ID. Remember, that's your hardware identifier in your mobile. It's now called the PEI, the Permanent Equipment Identifier. Your MSISDN, which was always kind of a strange name, Mobile Station ISDN, Integrated Services Digital Network. That's kind of a long name for your telephone number, which your MSISDN is your telephone number. Well, they've even though we all know it as your MSISDN, has been changed to the GPSI, which is still your telephone number, the generic public subscription identifier. Your MC, that's a little bit different now. Your International Mobile Subscriber Identity is now made up of a permanent identifier, SUPI, and a concealed identifier, SUCI. So it's still, the MC is still contained in there, but it's a method where the network doesn't, in other words, the mobile doesn't give up its MC anymore like it did in second, third, and fourth generation systems. It comes up with a concealed identity, and then the network figures out who you really are based on that. Your globally unique telephone ID, which is like your temporary number, is the same thing, and now it's called the 5G GUTI. So as kind of just a review then, we looked at the different eras, from the 1980s and the 1990s and on the way through the 2020s. And these were the different systems, the different generations. Some of these were point generations, like 2.5 or 2.75 or 3.5. And this is what they called them. They called the second generation GSM, Global System for Mobile Communications, General Packet Radio Service, Enhanced Data Rate, I think it was for GSM or for Global Evolution, Universal Mobile Telecommunications System, High-Speed Packet Access, Long-Term Evolution, and LTE Advanced, and finally New Radio, Next Generation Core Network. So just kind of names given to these different generations. And again, just kind of a summary of these. If you look at first generation systems, there were various organizations and various technologies. There was no one technology. They were kind of all over the place. Second generation, recall, there were several of them. The primary one was written by the European Telecom Standards Institute. That was GSM. The Telecommunications Industry Association, Electronic Industry Association, which was based in North America, they had various technologies. There were quite a few technologies in the second generation: digital lamps, cellular digital packet data, integrated digital enhanced networks. Again, just a lot of acronyms. But again, remember when we talked about second generation systems, there were various. By the time you got to improving the speeds, in 2.5G is when packet technology came out. So you had general packet radio service, you had high circuit, I forget what that acronym stands for, high speeds circuit switch data, I believe that is, and then edge. And again, there were other various technologies in 2.5G. 3G, that's when the standards went from, the GSM standards were a third generation partnership project. The CDMA North American standards was 3GPP2. So you had two different organizations plus IEEE. That was your mobile WiMAX. So you had, again, these were the technologies in 3G. By the time you got to, and then they improved to 3.5G, high-speed packet access and the uplink and downlink and so on. But then by the time you get to 4G, Once fourth generation came, there was really two technologies, one by 3GPP called LTE Advanced, and 3GPP2 was still making an attempt at that time, and they had something called UMB, Ultra Mobile Broadband. In 2008, 2009, Qualcomm, which is a company out of San Diego, California, Qualcomm dropped all of its funding for UMB. It was pretty obvious that the world was going to one standard, that was LTE. So from 4G on, the standards are all written by third generation partnership project, LTE Advanced, and now, of course, for 5G the same way. If we look at the signaling, what type of signaling through the generation? Now, this is a rather busy slide, but just to kind of go over it, in second generation systems, and this doesn't show all of the devices, but just to show the signaling. The primary signaling protocol in second generation systems was SS7. SS7 communicated with the home location register. If you were visited, if you were roaming here and this was your visited public land mobile network, you still need to communicate with the home network. And again, that would be through SS7. So SS7 is the primary signaling protocol. By the time you got to 3G, you had a new protocol for tunneling, GTP, GPRS tunneling protocol. And that was to tunnel data packets. So these data packets would be tunneled through from the cell tower to the serving GPRS support node, and then out to the gateway GPRS support node, and then to the packet network. So your data packets here were funneled here, but for circuit services, you still communicated SS7. So SS7 and GTP were the primary signaling protocols. In 3G, they also introduced this optional architecture called the IP multimedia subsystem. And the fourth generation, which changed several things. Now in the fourth generation, you had a mobility management entity, which was your controlling device. You had your serving gateway, which was kind of like the serving GPRS support node. You also had a packet PDN gateway, a packet data network gateway, which got you out to the world, either through a packet network or the IP multimedia subsystem. And that protocol is GTP. But now in 4G, you also had a mobile phone that had SIP. SIP is Session Initiation Protocol. That's what's used to set up a voice over IP call. So if this is a SIP-enabled phone, that SIP signaling would go inside these tunnels, these user tunnels, and then be handed off through the P gateway and then handed off to the IP multimedia subsystem. Same thing if you're roaming. You have a GTP tunnel from the serving gateway in the serving system to the PDN gateway in the home system. The primary protocol, though, to talk to the home subscriber server instead of SS7 is now diameter. So diameter in 4G kind of takes the place of what was SS7 in 2G and 3G networks. So the two primary protocols then in 4G would be GTP, GPRS tunneling protocol, which is again, think of it like a VPN, think of it like a private packet within a packet. And that's called GPRS tunneling protocol. And diameter. Diameter is the other primary protocol. Fifth generation, things changed again. You still have a SIP-enabled phone. You still use those same GPRS tunneling protocol tunnels, but your communication path between functional entities, between these software-defined functions is now HTTP2. So all that communication is HTTP2. And the other big change is interconnecting. All of these protocols here that interconnect, all of these protocols here, SS7 and GTP and diameter, all of these protocols are not secure protocols. They need to be protected. They need some kind of firewall, something to protect them because they are legacy protocols. Whereas now this is a secure protocol. It's HTTP2, but it goes through this kind of like think of it like a built-in firewall, SEPP. This is the Security Edge Protection Proxy. So I know this is a kind of a busy slide, but it just shows you that through the generations, we have different signaling methods. And for the remaining time we have now, we're going to review these. We'll look at SS7, We'll look at diameter, we'll look at GTP, kind of a high level look at all these protocols and what makes them unique and just how do they route and just what are some of the key fields in them. Some of them are fairly complex protocols. You look at SS7. SS7 covers all the layers of the OSI model. It's everything. So it's kind of it's a fairly complex protocol. Other protocols are application layer protocols. SIP is an application layer protocol. So anyway, I think we'll take a look at those. So this is what we've covered now since the first of the year. We've looked at mobile telecom basics, just some basic principles of the radio, some basic principles of handovers and just things that happen in a mobile network. And then we looked at the industry as a whole. We looked at the mobile identities. And remember, there are some very important identities. Your IMSI, your International Mobile Subscriber Identity, which identifies your mobile country code, your mobile network code, who your network is, and then you as the user there. It's a very important identity that identifies you uniquely, and it's only known in your SIM card and in the authentication center. It's fairly secret, but it's one that's people that fraudsters, people that nefarious hackers, they want to get that because then they can assume your identity. It's a very, very important identity. Your MS-ISDN, your mobile station ISDN number, which is your telephone number. And remember, there are 3 types of digits in mobile telecommunications. One is an E.164. That's a number that's in telephone number format, like your telephone number, your MS-ISDN. And entities in the network, and mobile switches and VLRs and home location registers, they're assigned a non-dialable number, but it's in E.164 format. The other type of format is E.212, E212, and that's an IMSI, an International Mobile Subscriber Identity. And that's the one that's made up of your mobile country code, your mobile network code, your mobile station ID, 15 digits. And then the last one we haven't really talked much about is can be a little confusing, but it's called the Mobile Global Title. It's called an E.214. Just think of it as a combination of those two, and it's used for routing purposes. So we went through a lot of identities. We looked at the different generations. We briefly mentioned the first generation, but then look at the second generation and the architectures and some of the things that changed. Not a big change between second generation and third generation. It was the air interface changed. The biggest change came from third generation to fourth generation, LTE. From fourth generation on, everything is data. There's no circuit services. You can fall back to a circuit service, but the core network itself is strictly data. So, when we looked at the architectures, we looked at some of the motivations. What was the reason? And data was a big thing, especially in 2008, 2009, with when mobile phones were just taking off like crazy as far as amounts of data. Then we looked at different protocols, the lifeblood, and the key protocols are really SS7 diameter, GPS tunneling protocols, SIP, SIGTRAN, signaling transport, that's transporting SS7 via IP, and HTTP. So those are kind of the 6 protocols that we'll look at next. No problem. Yeah, well, if you want to stop this recording now, and then we'll start a new one. I'll just start the protocols. We'll get them started because we got about 15 minutes left. Okay. Well, some of the big differences were here. Let's take a look at some of these big differences here. First of all, the big differences, if you look at the core network, the 5G core network, previous generations had defined entities, defined hardware. You had a visitor location register, you had a home location register, an authentication center, a message center. You had all these different defined hardware, and the communication between them was defined. So an MSC talked to a VLR talked to an HLR, and a message center talked to the MSC, and they could communicate with each other, but not all of them. In other words, an HLR didn't communicate with or an authentication center didn't communicate directly. It was always through the HLR. So there was in many cases not this direct communication. In 5G, it's more of a software defined network. So all of these functions now can communicate with each other. So the architecture looks something like this then. So the architecture is, instead of having point to point where certain network entities talk to only certain other network entities, now they can all communicate together. So you got these different functions that can now each communicate. So they would register themselves on a network repository function, and they would tell that network repository function, here's what I'm capable of doing. Here's the services that I produce. And if anyone needs those services, here, I'll raise my hand. Here's my IP address on my port. So these network entities, which were network entities, are now network functions. And these network functions don't need to be located. They can be anywhere. They could be in a customer premise. They could be at the radio access network. They could be at the edge of the network. They could be in a regional or a national data center. So instead of a design where only certain entities talk to each other, now everyone can communicate over a common, think of it like a bus, a common point like it shows here. So all these different functions can communicate. All these different functions can communicate over that common bus. So that's probably the biggest difference in 5G, is that these network functions use services, so they're consumers of services, and they give services, they're producers of services. So they use and give services. So rather than just keeping what I have by myself and only allowing certain entities to communicate with me or use my services, I offer my services to everyone. The other big thing is, remember, all these protocols. When you look at the different protocols that a 4G network and a 3G network has to understand. Remember, if we look just at a 4G network, let's just take a look at a 4G network. This mobility management entity talks diameter here, talks diameter here. It talks S1AP here. It talks GTP here. If you have circuit switched fallback, it talks SGS, application protocol here. So this thing has all kinds of different protocols that it needs to understand. But now you've gotten rid of all that. With 5G, you get rid of almost all those protocols, and you have just one common protocol, HTTP, and HTTP2 specifically. So that's kind of the biggest difference on the core network. The core network is now software based, and they communicate with standard APIs. What's that now? I'm sorry, and I didn't quite. Yeah, I heard that. That's that high pitch in the background. What was that again now, Raphael? Oh, the signaling, the different signal. Yeah, the signaling. Yes, and now the signaling is, yes, quite a bit different now in 5G. So it uses just one common HTTP. There are a few other protocols. There are a few other ones that are used out there, and we can identify those. But I thought that the next thing we could probably do from here is start to look at some of these signaling protocols. Does that make sense? Is that a good way to go? Okay, I know. Are there any questions that you have on any of this material? Any questions? Before we will at least introduce, we only got about 10 minutes left, but we can at least introduce what we're going to talk about next. Okay. Okay. All right. Let me put up another slide here. Um, we're gonna have to do. I'm gonna do. This is a different. I'm going to get them into your slide format, but for now we can do this. This is the Celsius format. I'll get them into the Celsius Academy format. But I think we're going to take these now. What I would like to do here is start taking a look at the core network signaling protocols. What is what is SS7? What is diameter? What is GTP? And just again, we're not going to go into tremendous detail, but enough detail to understand what key pieces of information are carried in these protocols. So, and that, if you understand the generations and just have a high level look at how these signaling protocols work, think that'll help you a lot. So these are the top six. Signaling System 7, which is kind of like the crown jewel of signaling protocols in telecom. Diameter, which is used in very much in 4G networks, using the IP multimedia subsystem and 4G networks. GPRS tunneling protocol, that's that VPN-like protocol. GTP is used in 2.5G, 3G, 4G, and even part of 5G. SIP, Session Initiation Protocol, used to set up a voice over IP call. SS7 is used to set up a circuit switched call when you use dedicated circuits. But SIP is used when you're setting up a voice over IP call. Now your voice is converted to data packets, and whether it's your voice or you're tapping out something, data is data. HTTP, specifically HTTP2, which is used in 5G networks. And then SIGTRAN, not really a signaling protocol per se. SIGTRAN is a way to deliver SS7 messages over IP. So instead of having dedicated 64,000 kilobit per second, 64,000 bits per second, 64 kilobit per second, dedicated links to connect these nodes together. Now these nodes are connected together via IP or Internet Protocol. So let's just take a look at these, and again, we're going to I'll put these in the regular format. Hopefully by next Wednesday, we'll be able to look at that. So these are the items that I plan to cover. We're going to look at the different telecom signaling protocols. SS7, yeah, please. UTRAN, UTRAN is UMTS Terrestrial Radio Access Network. That is the 3G radio. When you look at the 3G radio made up of the node B, which is your cell towers, and your radio network controller, those things are UTRAN. So UTRAN would be this. Hold on one second. UTRAN would be this. Let's go back here. UTRAN would be this right here. UTRAN would be this. The node B and the radio network controller, that makes up the UMTS terrestrial radio access network. SIGTRAN is delivering these nodes here. These links are IP based. Normally, these links that tie all these devices together, when SS7 first came out, these were what were known as low speed links. A low speed link is 64,000 bits per second. In the 1990s, there was a technology called ATM, asynchronous transfer mode. And what that did was it increased the speed. So instead of 64,000 bits per second, I can now transmit SS7 message at 2.048 megabits per second. So now it'd be like the street in front of your building there. Instead of 20 kilometers per hour, you increase the speed to 500 kilometers per hour. So you can get more traffic through there. In the early 2000s, they improved that again by having IP-based links. Well, when you talk IP, you don't have dedicated links. With IP, it's more of a virtual link. So it's still a link. It's called an association, but that's what SIGTRAN is. SIGTRAN is signaling transport, which is different than UTRAN. Does that make sense? Okay, good, good. So this is the areas that we're going to cover starting next week. We're going to look at the different mobile telecom signaling protocols. We'll look at SS7, well established, very well established, international telecom signaling standard. There's actually two different versions, one for ANSI, American National Standards Institute, and one for ETSI, European Telecom. The ITU European is really the one that's used mostly in the world. But it's used in the public switch telephone network. It's used in the wireline network. It's used very extensively in second generation and third generation networks, and it's still used for roaming today. Still used for international interconnection. It still has a lot of uses today. Diameter is also a signaling protocol, and that's used extensively within what's known as the IP multimedia subsystem. Remember, we talked about the IP multimedia subsystem. That was release 5. Third generation was release 99. Next came release 4, and then came release 5. And with release 5 came this IP multimedia subsystem. Inside the IP multimedia subsystem, there's a couple protocols, one being SIP, Session Initiation Protocol, one being Diameter. Then several releases later, release 6, release 7, release 8. Remember release 8? That was an important one. That was where the architecture changed. That's LTE. Diameter is used extensively in LTE. So Diameter is a lot of different interfaces use Diameter. So this is more of SS7 is a 2G, 3G. This is somewhat, just think of it as somewhat the replacement of SS7 for 4G. Not totally, but that's kind of, they both do similar things. They do mobility management, they do authentication, they manage the subscribers session, and just things that, as far as the mobile is concerned, that's SS7 and 2G, 3G, and Diameter 4G. GTP. Yeah, this is a tunneling protocol. This encapsulates data, and it first appeared in 2.5G. Then it was in 3G. Then it was all over the place in 4G. Then it was even in the user part of 5G. So GTP, GPRS tunneling protocol, which is like it says, it's a tunneling protocol. It's not the only one. There's many tunneling protocols, VPN, generic routing encapsulation. There's a lot of different IP security. There's a lot of different tunneling type of protocols. SIP, yeah, Session Initiation Protocol, used in the wireline and wireless networks for voice over IP. So it's used to set up and to tear down a voice over IP, just like SS7 is used for circuit switch. HTTP, and specifically HTTP2. That's the foundational protocol on the World Wide Web. When you type in www.anything.com, it takes over from there. It's a client server type of protocol. It's been around for quite a few years. Latest version, I think, is HTTP/3. I think is the latest version. SIGTRAN is a group of protocols, and that's used when you take SS7 and you transport it over IP. So instead of a dedicated link, instead of a dedicated path between two devices, you still have a path there, but it's virtual. It's IP. It's just anything that's IP. It's there, but it's not really there. It's not dedicated. So what we want to do, though, we don't want to tear apart these protocols and look at all the zeros and ones and what all these different fields. That doesn't serve anything. We do want to see where they are used and how do they route, and what are some of the key fields in there? What are some of the key pieces of information? Things like telephone numbers, things like IMSIs, things like location identities, and just kind of how do these things actually communicate? And then we'll include some references. It's always good to know where you get some additional information. So that's kind of the areas we'll start on Wednesday, and we'll get into what I'm going to call a shallow dive into the signaling protocols. This is where we'll start up. Yeah, that'll be good. And we'll start on some of these signaling protocols. Absolutely. So enjoy the rest of your evening and your class and your weekend. And cheers, everyone. We'll see you next week. See you next Wednesday. Have a good one. Bye bye now.